is a video designed to help future rink builders learn all the tricks of the trade, techniques, and processes that are going to be required to put their rink in construction and operation. This is a 100,000 square foot building being built by Burley Rink Supply for the purpose of becoming a technological training center for ice rink construction and management. This is the early stage of the construction process. The site work's been accomplished and in the process of pouring foundations to get the site ready to accommodate the structural steel to house the complex. The complex will be a combination of a full-size regulation ice rink, the manufacturing facilities for Burley Rink Supply, and also the corporate offices. The goal will be to bring people in from all over the country, and all over the world for that matter, to learn how the equipment is manufactured and actually see the equipment in operation. It'll also allow those people building a rink the opportunity to have their management team come into Burley Rink Supply facilities and be trained in every aspect of arena management, operations, marketing, promotion, setting up profit centers, and literally everything it takes to running a rink the most efficient way possible. Of course, before getting to this point, the hard work really occurred. Construction we find with ice rinks today is the easy part. It's getting through all the hurdles of planning, design, budgeting, finance, code compliance issues, stormwater management are really the task at hand. We'll be going through all of those different processes and the hurdles that we had to complete ourselves at Burley Rink Supply in this video. Like any business investment, location plays a primary role in the success of any business. The site we selected is located very close to a new $300 million mall shown now called the Galleria in Johnstown. It's the largest growth area of the community and represents the biggest retail outlet in this western Pennsylvania area. The goal was to find a very easy to find location which was yet affordable. You can see there's the business park sign where we've selected our project. We essentially went into an industrial park where the acreage was sold at $35,000 an acre. That in contrast to a quarter mile up the road here on these out parcels and these surrounding properties where they're selling for anywhere from $150,000 to $250,000 an acre today. The property and project that we have budgeted for combined manufacturing and ice rink project that is budgeted in construction at about $3.7 million was appraised in the initial bank review at $4.4 million. This whole entire area will be developed. The goal is to select a piece of property which is economical yet not so far away that a potential competitor could build a rink close to the market source and actually cut your facility off from the primary market. So while those locations real far away may have real cheap property, it's a kind of combination of both where as long as you're about a 15-minute drive away from the primary market, you may still be alright. If you get much further than that and another rink opens up in a year or two later, closer to the market, why would people drive that extra half hour to your facility? Here we are at the entranceway of the industrial park where we're putting the rink at. The mall shown just earlier. And this area is just being developed right across the street from the mall. Industrial development and the site where the complex is being built. Today's a big day for the project. You can see the cranes arrived and they're planning on starting to erect the structural steel for the building. You see the crane and all the cross member supports being attached to the main structural beams over in this location. Foundations have been put in place and the masonry walls are beginning to go up. The structural steel columns here are shown in a red oxide, which actually was a mistake on our part. There was a miscommunication. When you order your steel, you should be always ordering it in a gray primer as opposed to the red primer. The benefit of that is when you paint the beams in place, the red oxide is very, very hard to cover with most of the conventional colors that you're going to use for an ice rink construction. Typically a blue or a white will go over a gray much, much easier, and there's no upcharge by the manufacturer for doing that. With businesses today relying so much on computers and ice rinks also following that suit, one aspect of a pre-engineered metal building is the ability to have the building grounded and not have a lot of noise in the building from the standpoint of computer systems. Often, where the connections are made with the steel columns, a good connection isn't achieved and the overall building grounding isn't affected. And when you have elements like beepers, cellular phones, and even the widespread computers that you'll have in your various profit centers of your ice rink, you'll find that you have a lot of problems with it if they don't ground the building properly. So attention should be paid to that priority. Typically, the pre-engineered metal buildings use some type of a tie rod arrangement to tie the columns in to either the concrete floor or to each other with a tie rod that runs completely across the rink floor. It's important, depending on the design of your foundation, your building, that this is coordinated with the rink system. Also, the structural engineer needs to remember that the rink floor often does not have a concrete floor across of it, and even if it does have a concrete floor, it is not poured as one piece. It's separate from the overall building slabs on grade around the perimeter of the floor, and cannot be used in his calculations for the tie rods. The tie rod depth typically has to be at least 12 to 21 inches deep, depending on where they're located on the rink floor. If you consult with Burley Rink Supply, they'd help you locate where those have to be at and what depth, so there isn't a coordination problem. All the inner foundations are insulated with a dowel board. The outside of the foundations around the rink, even though not shown yet, will be waterproofed fully. Remember, an ice rink is like a cold storage facility. The primary goal will be to provide a vapor barrier on the outside of all the walls, floors, and even roof structures that adjoin to the ice rink environment. Moisture is constantly going to try to infiltrate the space. It's very much like a cold glass on a hot summer day. Moisture is constantly trying to pull through everything. The insulation package and the roof will spend time on. All the slabs on grade have to have vapor barriers underneath the slabs on grade, so water doesn't wick up through the concrete and create problems for rubber flooring adhering and just rubber flooring gathering moisture underneath and becoming odor-ridden. The columns of this building were actually shown by the structural engineer as being square. The contractor, in coordination with the design engineer, determined that the sonotube arrangement would be actually more economical in a construction basis as opposed to doing square forming, since that's readily available in the construction industry as far as buying and placing sonotube. More shots of the structural steel. The company who supplied it, participating in the training facility. All the vendors on this project have been very, very cooperative. We'll give them all credit at the end of the project by name and location, and you'd be more than willing to, or more than able to contact any one of them. This is the foundation that separates the rink environment from the actual core. You can see how the foundation's broke here, and the reason for that is we have to run the transmission lines from the rink floor system out into the area where the rink is. Always remember that either a form out or a sleeve arrangement has to be created to coordinate with the needs of the rink contractor installing the rink floor. As our foundation continues around, we come to the location where the emergency stairway exit will be located at. Of course, that has to be a 1-hour fire rated enclosure, and that's why block is the whole way around it. That 1-hour fire rating will continue all the way up to the roof structure. As you will see with the progression of this project, you'll see an awful lot of construction work being done on the side where the ice rink is, and the manufacturing side actually following later on in the project. The goal is to be open for the fall-winter season with the ice rink, and the timing and when we could get permits and get the project underway was justified working on the ice rink portion first and getting that up and running for an October date. The manufacturing, in all reality, we wouldn't want to move into to the very end of the manufacturing season, December, January, when from a construction standpoint in the ice rink industry, our manufacturing period is at its slowest. To try to move into this portion of the building earlier than that would not be practical anyway. We're now standing towards the front of the building, where I'm showing the elevator shaft that's required for the second floor of this project. In any project where the second floor is over 3,000 square feet, ADA requirements dictate an elevator. And this will be our elevator. And we'll give you some guidelines of what the minimum requirements are of a 2,000-pound elevator lift to meet ADA requirements. Remember that 3,000-foot rule. If you have a mezzanine and you're just wanting to show or provide spectator viewing from an upper area over the ice sheet, and that space doesn't consume more than 3,000 square feet, all you need to provide is a stairway to that location, and no elevator or chairlift is required. One important design criteria of an ice rink is to provide a low emissivity ceiling over the ice sheet. Oftentimes, existing rinks find they need to retrofit this type of package into the structure, which is very costly and time-consuming to the operations of the facility. A well-built and planned project from day one can be built with a low emissivity ceiling without the need for extra cost at all. That's where the importance of the planning comes from. What you're seeing here are the purlins which are used in the building construction. As you'll note, they're galvanized. The reason for that is galvanized, the surface of galvanizing, provides a very low emissivity finish, which is very close, if not almost equal, to aluminum. This, combined with the unique insulation package, provided a very economical yet very effective low E ceiling, and we won't have to pay any extra money to have a retrofitted low E ceiling put in this complex. We'll go through the whole process of how we did that. But galvanized purlins were very economical by comparison to painted purlins. It's not that much of an upcharge. Relatively, this whole facility will have a very efficient low E ceiling for approximately $3,000 to $4,000 over the original construction cost. Here shows the foundation on the exterior being sealed with a tar type sealer, and the reason for that is to keep moisture from penetrating through the foundation wall into the rink area. All the soil within the rink space, which is basically shown right here, will be below dew point temperature for the outside soil conditions, and without sealing it, you'd have water constantly wicking through all your foundations and foundation walls. Once the foundations are done and the pre-engineered metal is delivered to the site, erection actually takes place in a very short period of time. As you can see, in only a few day process, the entire core steel has already been erected in the air. Typically, a single rink complex erects all the steel and skin in about a 4-week period. A twin rink can take anywhere from 6 to 9 weeks depending on the complexity of the project. Close observation will show all the purlins are the galvanized structure, which the role of that will play more importance as we go through the construction process in more detail.
Zipping around the ice, zipping around the... Yeah, they're going to New York City tomorrow. They did a lot of digging on their foundation yesterday, which was good.
Yeah, that.
Nice little camera.
That's exactly what it's doing.
Yeah. And then I can do a replay. It's like a VCR type thing. Here the formwork for the honch is being prepared within the rink space area. You can see the honch is actually at a lower recessed area than actually the rink floor is. We'll go down 16 inches rather. Typically what they'll do is put the formwork on one half of the rink, pour it, and then move it over to the other side. Forms are typically steel formed, wood formed, plywood, anything of that nature. See the method that they used here for mounting the form, so they can go ahead and use those turnbuckles to turn in and out the form to make the dimensions underneath the rink floor area. You can see here the perimeter they're laying a block down as opposed to pouring the floor integral to the outside perimeter. And the reason for that is they want to start the sidewalls and get that going before they actually have the floor done. Right now we're about the end of August and we're concerned about weather turning bad, so they want to get the building closed as quickly as possible. These hairpins off the columns, shown right here, will be actually poured integral into the floor, the perimeter floor. Well, on the outside, looking into the rink area on the perimeter, the forms are not going to be finished in this fashion where they're just irregular in height. The overall height of the curb on the perimeter, especially right next to the rink area, is very, very critical. So what they'll do is they'll have an internal form line of which they're pouring the concrete to. That still hasn't been shot by a laser or put onto the forms at this time. Externally here, we're in the one corner of the rink, outside on the radius. What they'll be doing is they'll be putting a vapor barrier down on all the slabs on grade within the perimeter. So this whole area will be dressed and covered with a vapor barrier. And the purpose for that is so moisture will not wick up through the concrete slab underneath the rink floor, rubber flooring rather, because of the cold environment. Concrete is very porous and water would normally wick up underneath the rubber flooring and cause the rubber flooring to be wet or even fail on the mastic or the glue that's used to put it down. Emergency exit door framing being put in place. Been having very, very good compliments about the Balin building from all the contractors here. I feel the quality of the building is superb. We're standing near the mechanical room area, what's becoming the mechanical room. The masonry is well underway. The snow melting pit is already in place. This is a concrete septic tank as opposed to a form-in-place concrete pit. The masonry walls will be supporting the second floor dock plank. That's the reason for the masonry going the whole way up. The fire-rated stairway had to be put in, emergency exit purposes. The masonry block that they're putting up is including a reinforcing bar going vertical, approximately 4 feet on center. Let's see if we can take a little picture of it. There you can see it pointing up through the top of the masonry wall. Now those cores are filled with a grout condition, and that's to add structural integrity to the outside wall because it's 18 feet high to the point of where the dock plank goes. Combination of it supporting the dock plank and its overall height dictated that the engineer wanted those filled with grout and reinforced. This again is a snow melting pit, and what we did is use the precast concrete septic tank, of which we threw the lid away. And now what we'll do is we'll dowel into this tank with some reinforcement steel to integrate it into the overall flat slab on grade in the mechanical room area. The benefit of this is a typical 4x8 tank, of which can be used in the snow melting pit, with an approximate investment of $200 to $300, as opposed to potentially $3,000 to $5,000 for a form-in-place type pit. In the project, we have people still putting up purlins and the structural steel. The masonry obviously is being worked on. All the foundations for the future masonry obviously all in place. We've got contractors finishing up and running all drain connections that are required. We're at a stage with the project that we're going to be installing the transmission lines, and they're starting to put the cladding up on the outside of the building. We'll shoot some footage of all of that. These are the transmission lines for connection from the mechanical room floor and distribution of the secondary coolant fluid from where the mechanical room is actually into where it's distributed on the manifold on the rink floor. As you can see, they're all prefabricated and equipped with flanges, so the connection in the field is relatively easy. These are primed and will be fully insulated after they're put into place. Internally, the building is still being prepared. The workers are setting up the caging for the reinforcement steel, which will actually be made part of the honch around the rink perimeter. After these are prefabricated in the manner they're doing, they put them into position and chalk them up as shown here. At this stage as well, you can see all the cross members, at least for the rink area where the insulation package is going to be installed, has been attached to the purlins. There was a bunch of discussion whether or not the structural beams should be painted before the purlins went on. The determination is from the contractor that with the wind on the site and the adjoining other properties, they were concerned about painting them in the air and having overspray hit the other properties. We're currently standing approximately on the red line of where the ice rink will be. You can see this depressed area where the honch is actually going to be formed. And then also we're taking pictures of the trenching, which is where the transmission lines will be located at. This trench goes the whole way back to the mechanical room. We need to make sure these are in place before the outside concrete perimeter is done. This is where it's very important to make sure there's coordination with tie rods, if there will be any tie rods on the main structural beams from side to side, and all underground plumbing. Once we get to the center like this, we jog right to the center, and now we're looking right across the red line of where the ice rink will be. We're standing in the trench. Like every aspect of the total construction, the area where the transmission lines are no different. We need to make sure that we have a soil that's not going to be an expansive type soil, that it's compacted properly, and of a material that won't damage the piping when we do backfill around it. After the pipes are leveled and placed in this location, we will be covering them with a sand-type material. The piping, which has been factory pressure checked, they're beginning to pre-insulate it, and they want to insulate it actually outside the trench first. We're using a 2-inch urethane type insulation, which is a closed cell foam. Won't be impregnated by moisture in any fashion. And then the workers encapsulate that with a PVC jacket, which is a solid vapor barrier around the insulation as well. We don't want to use any type of rubber type insulation because the soil will get wet over a period of time and would damage any insulation that was not water impervious. We're looking at the other direction of the trench, towards the center line. First, we're standing where the Zamboni and mechanical room will be. You can see from a coordination standpoint, we needed to make access for the pipes. The pipes will be running right through this location. This could normally be either sleeved or it can be formed so there's an opening at this location, but normally this foundation work is done before the transmission lines are placed. Again, we're looking into the mechanical room area, of which where the chiller will be located at, and the Zamboni, which is the snow melting pit that we saw earlier. In this particular application, we have our transmission line going the whole way across the room, and the reason for that is we're going to have an additional set of stub outs on the far side of the room for hooking up manufactured chillers and running them under a load of the existing ice rink, void of the chiller that's going to be the permanent chiller for the ice rink operation. This room is to become what the boiler room. Here we see the water surface coming up. This line will be connecting for a primary water surface as well as fire protection. You can see the sidewalls are beginning to be installed with the insulation package, which we're going to go over and take a look at. Externally, site conditions continue to take place. Here they're running electrical and phone line connections from the outside service to the building. We're over where the crew is putting the sidewall and insulation package up. As you can see, you have a white scrim on the inside of the envelope. As the insulation package progresses, you'll see that the low emissivity or polished aluminum is very critical on the roof, but is not nearly so critical on the sidewalls, and in fact seems to deter away from the atmosphere. Based on how the radiant loads are to an ice rink application, the angle at which the surface is to the ice sheet plays a big role in the importance of the low E, and because the sidewalls are not in a true horizontal plane over the ice sheet, putting a low E material on the sidewalls wouldn't actually have any measurable benefit to the project. The insulation package being installed here is an R19. The insulation being provided by a company called Thermal out of Ohio. They're very cooperative on the overall project. You can see this is a very durable internal vapor barrier. Externally, before the metal panel goes on, we're putting in a complete vapor barrier, and the reason for that is that the pre-interior metal building, even though they're sealed and they appear to be vapor tight, they really are not. The ice rink itself will have a constant moisture infiltration trying to get into the ice rink at all times. And by putting up this external vapor barrier, it'll reduce the possibility of condensing within the insulation membrane. We want to stop the moisture before it hits a surface that's actually below dew point conditions for the outside weather condition. And that's the purpose for this vapor barrier. The sidewalls are not nearly as critical as the roof structure. Accordingly, the internal scrim on the sidewall insulation is not perforated as the roof will be. You'll see with the roof installation when it goes in that we'll have a vapor barrier on the outside, and then the low E material on the inside will be actually perforated. One blue building. You see how the insulation comes in rolls. For our particular application, when we ordered the insulation, we ordered it without an external vapor barrier, and what's being done is they're putting in a separate polyethylene 6mm poly layer on the outside for a vapor barrier. You see from the concrete work on the base, with the bottom purlin, and then how the dressing is going to get installed.